Alright, so going over number one, you had to use the product rule on x squared cosine of x. For the second part of number one, you had to use the chain rule. And so the 1/2 drops down in front, subtract the power by 1. The derivative of the inside part is going to be 8x. And then you can reduce the 8 and the 1/2 to get you a 4x. And that's how you would simplify this derivative. For number two, you had to find the derivative of sine of 2x. The derivative of sine is cosine. You keep the inside the same. Now the derivative of 2x is 2, so that's why the derivative is 2 cosine of 2x. From here it wants you to plug in pi over 6, so you plug in pi over 6. Since you're multiplying it by 2, it reduces to pi over 3. On the unit circle, cosine of pi over 3 is equal to 1/2. So you can kind of think of this as basically 2 times 1/2, which gets you 1. So these are the points are distributed. For part B, you had to find the second derivative, so you just take whatever your first derivative was and find the derivative of that. And so the derivative of cosine is negative sine. Because you have to use the chain rule again, you'd multiply it by 2. And so 2 multiplied by the previous 2, that's how you get the negative 4 out in front. For number 3, it's saying that the line tangent to this curve, this is the line tangent to the curve. You want to find the value of b. So this tangent line has a slope of 2. You can find the derivative by doing the power rule by dropping the 2 in front, keeping the inside the same, and so this is the derivative. So basically the derivative needs to equal to, that's what the slope of a tangent line is. So you set this equal to each other, you solve for x, and you get the x coordinate to be negative 2. Since your tangent line needs also a y coordinate, you're going to plug in this negative 2 into the parabola equation. So I plug in negative 2 into here, which is what I did over here. So my y coordinate is positive 1. So now that I have both my x value and my y value, I go back to the tangent line. And then from there I can plug in the x and the y values I just got done finding. And you solve it for b equal to 5. For number 4, you just use the quotient rule. And you use the table of values to find g of 3, which in this case happens to be 4. And then when you get to the derivative, you just find the derivative g prime of 3, which is negative 2. And it simplifies to that. For the backside, you have to use a product rule. When you're looking at the value of f of 3, it's just going to be what the value is at 3. And so f of 3, you can see on the graph, is equal to 3. And then for the derivative g prime of 3, that's going to be the slope of this graph at 3. So the slope at 3 is this line segment. And this slope is going to be 3 over 2. Because you can go up 3 and then over 2. That's how I get 3 over 2. G of 3, the value of the graph of g, also happens to be 3 over 2 because it's at 1.5 on the y-axis. And then the last piece is going to be the derivative of f at 3. So the derivative of f at 3 is measuring the slope of this line segment at 3. So this line segment has a slope of negative 1. It's negative down 1 over 1, down 1 over 1. So that's how I get this value to be negative 1. So you simplify all of this, and you end up with a 3 as your answer. For the last part, you had to find the chain rule. Because you have a composition, you have basically inside f of x, you have g of x. So the chain rule looks like this. I'm looking to plug in negative 1. So g prime of negative 1 is the value of the slope. So the slope here would be a horizontal line. So if I were to draw a tangent line, it'd be horizontal like this at negative 1. So since G prime is equal to negative 1, sorry, G prime at negative 1 is equal to 0. Excuse me. So G prime at negative 1 is equal to 0. This whole thing is going to become 0. So it's asking whether it's positive, and the answer is no, because G prime of negative 1 is equal to 0. So it has a horizontal tangent slope. Okay, and that's the solution for the first version of the quiz. Alright, so the second version of the quiz looks like this. So for number 1, you had to use the chain rule. So the chain rule is going to be dropping the 1/2 in front, subtracting the power by 1. Then derivative of the inside is 12x. The 1/2 and the 12 simplify like this, and that's the solution. Second part, you had to use the product rule, and then that's the solution. Number 2, you had to find the derivative. You have to use the chain rule. So the derivative of cosine is negative sine. And keep the inside the same. The derivative now of the inside, which is the derivative of 4x, is just going to be a 4. It's asking you to evaluate to plug in pi over 8. So I plug in pi over 8 into this, which simplifies to the pi over 2. Sine of pi over 2 is equal to 1. So 1 times negative 4 is negative 4. The second derivative is you just take the first derivative and find the derivative of that. This requires an additional chain rule, so the derivative of sine is cosine. And because you take the derivative of 4x again, you would multiply this 4 by the 4 that was already there to get negative 16. So basically y double prime would be negative 4 cosine of 4x, and because of the chain rule you multiply again by 4. So this 4 gives you the chain rule here, so 4 and 4 give you a 16. I already went over number 3, so you can look back at the previous video or earlier in the video. Number 4, you do the quotient rule. You get the values from the table. F prime of 3 is given to you as negative 3, and then f of 3 is given to you as 2. You can simplify this and reduce if you want to, or leave it like that, and it's going to be correct. For number 4, you had to find the derivative using the product rule. In this case, the product rule looks like this. When you get to f of 3, it's going to be the value of f at 3, which happens to be 3. So that's where this f of 3 turned into 3. G prime of 3 is measuring the slope. So the slope at 3 is the line segment right here. The slope of this line segment is 3 over 2. G of 3 happens to also be 3 over 2, the value. And then f prime of 3 is measuring the slope at 3. So the slope at 3 is a slope of negative 1 over 1. So that's how I get that value, and it simplifies to that. For the last part, it's asking if the tangent slope is positive, so you do the derivative with the chain rule. And what happens is that when you plug in g of 5, g prime of 5 is the slope at 5 of g, and the slope is of this line segment is the same as negative 1 over 1. That's how I got this value. G of 5 is the value at 5 of g. So g of 5 is 2. G of 5 is equal to 2. So then you end up with taking now the derivative of f prime of 2. So the derivative of f at 2. Well, the derivative here doesn't exist because at 2 the derivative, there's a kink right here. So this derivative does not exist. So the conclusion is it's asking if it's positive. You would say no because this derivative doesn't exist. So you can't say it's gonna be positive or negative. You would say the overall derivative doesn't exist because of the kink at 2.